Alright, well, hello everyone. Today we are going to be introducing our product, our senior one design of a differential thermostat. My name is Jay, Keith, Chenny, and Mazik. And so we proposed to make a thermostat that implemented another feature that most thermostats not have today. Nowadays, you see all the smart thermostats such as Nest and Ecobee, like at the top of the market, just for efficiency's sake, to allow our AC unit to run effectively and efficiently, and to help reduce energy at its best, better. The thing that we noted from the research that we have done on these, both Ecobee and Nest, is that we found that they use sensors and which help them figure out the temperature within the room that it's in. But the thing is, we feel like they don't do it as efficiently. Depending on the size of your house or like where the sensors are placed, it might not have an accurate representation of what the actual temperature is of the house. Or like if they pull information from the web to control the thermostat, the temperature in one part of the city wouldn't necessarily be the same as at your household. So what we proposed, or what we thought of, was like, why don't we make a thermostat that has a sensor directly outside the house and a sensor within the house that would regulate the temperature differences between the two, so that you can allow your thermostat to run the HVAC system, which is essentially the AC unit, to run more efficiently.
So why we think this is because of two specific reasons. From general physics, we know that heat transfer is because of a differential in temperatures of the outside and the inside. So for a drywall, we calculated and we found out that to actually make use of the maximum amount of efficiency in this heat transfer system, and like us putting in or taking out heat from this system, we have to look at this differential, and that is why we came up with this idea. And also we have a friend who did this manually and came up with this data, but this might not be the most reliable because he did it manually. He would go and he would change it when the outside temperature changes. Because of that, we think this would be a good approach, and this would have all this, the features, connectedness and everything of the old things that we have. We will implement it using an Arduino, and eventually we will take the Arduino out and put an actual Atmel chip in there, and it will be powered, the main assembly will be powered by the HVAC system, and the rest of it, the sensor that would be mounted outside, would be powered by a battery, probably not lithium-ion, because the static discharge is way too high. And we would like to open up the panel for questions at this point.
So, can you explain to me briefly exactly what it is about doing differential thermostat measurements, how that's going to allow you to reduce kilowatt hour use, other than the obvious that we decide that we're not going to run the AC as much because we've got, we're at a really hot time of the day.
Right. So there's that. But besides that, so there's this serial interface that connects to the Raspberry Pi, and we plan to use some sort of an API, a machine learning API, that goes and checks exactly what you just said, but in a more smart way. It will turn off the AC or the heating system if it thinks. So it's actually really trying to predict how much energy it will require to cool down or heat up the room to the set temperature that you programmed it at. But the computer knows better than what we think. So this would make the sacrifice on where to stop it, or where to stop the heating or the cooling system.
Okay.
So is that reducing the latency that it takes to do this or something? What's the...
So what you sacrifice is your control over the system, obviously, but you do gain a little bit of efficiency, and we think that this would make existing thermostats even more efficient. You need to take into account the differential, because that is what physics tells us, because that is how heat transfers. The heat transfers through the differential. We could take into account the differential and do the opposite. Go.
So I assume it's still set by inside temperature. Say I want it to run
Right. Yeah.
72 degrees. Right? So I said 72. So now the only variable is the outside temperature.
Yes.
Yes.
And you're saying that if you can track the outside temperature you can make your compressor more efficient. Is that what you're saying? I think.
Yeah, because if you run it outside of its maximum efficiency zone, if it heats up too much on the outside, what's going to happen is your AC system is now working overtime, and it's going to be outside of its maximum efficiency zone. If it works for too long, it won't be as efficient. It would just stop. It won't cool down the place too much, but it would waste more power at a certain point. So at that point, the computer makes a sacrifice and it turns it off, and it's like.
So you're gonna let it get hotter inside, even though I said
You're
it
gonna
was
let it get
72.
hot.
It's
Yeah.
gonna get hot.
You did
It's-
sacrifice
Oh,
everything.
okay.
You sacrifice
Yes.
a little bit of control over what you
Okay,
already
I got
set.
it now.
It's like-
So
it's like having an automatic
basically say,
transmission
too bad,
car.
it's too hot out, I can't keep it cold, therefore you're gonna
Yeah.
have to get hot.
Yeah, exactly.
It's not.
It's gonna be hot anyways, but this time it's gonna turn it off. It's gonna be like, yeah, we're gonna turn it off, but that
So,
way. it'll
Say
save
outside
energy.
it's outside 110, right? We had that, right?
Yes.
Yeah.
And then inside, you set it at 80, right? But
Okay.
it's not gonna catch up, right? It's gonna probably sitting at
Right.
82, 83. You're gonna turn off the HVAC, right? That's
Right.
what you're doing.
Yes.
Then the inside is gonna keep going up,
Right.
right?
It's gonna get
At
hotter.
what point is the guy going, is your intelligent system going to make a decision to turn the AC back on?
See, we're working on that sort of. We are gonna use the machine learning API and see what it can spit out. But yes, there has to be a point at which it turns off this differential and turns the AC back on, because it's like we've done this for 10 minutes now and it's not working. Like it's rising up even more. So a differential has to go in either direction. It has to be like, if it's higher than this, then turn it off. But if it gets like even higher, then turn it back on. Like you said right now.
So what's your chart showing? I mean, remind us?
This one?
Yeah.
Oh, this is just numbers from doing it manually.
It's the power consumed versus
Yes.
how much do you have.
So how much current are you allowed to take off that 24 VAC that you're gonna use for your power?
From what I remember, it was like 1 amp.
Is there a spec on that says that you can
Yeah,
pull an amp?
yeah, there is. I'm pretty sure it said 1 amp, but I did look up everything, and
Okay.
there's a certain point at which it'll cap out. But we're not gonna approach that point at all. Like ours is way under that.
Okay.
Yeah.
All right.
Thank you very much.